The Fundamental Theorem of Calculus, Part 2. This is the part about integrating the derivative. That is, if f prime of x, if capital F prime of x is little f of x, when we integrate this derivative, we get back what we started with. That is, we get back capital F. Except, it's in a little bit different format. Since we're integrating from a to b here, we have a definite integral. And what we get back is a definite number. It's the original function evaluated at the top limit of integration b, minus the original function evaluated at the bottom limit of integration a. This is, again, provided that f is continuous. Let's see an example of how we can use this. Let's look at the integral from 0 to 1 of 3x squared dx. Using this Fundamental Theorem of Calculus Part 2, we can figure out a value for this. What we have to do is we have to recognize that f of x in this case is this integrand. So f of x is going to be equal to 3x squared. Now what we need to do is we need to figure out what this capital F is so we can fill in this side. And the property about capital F is that the derivative of capital F has to equal 3x squared over 2. So for capital F of x, we have to think of a function whose derivative is 3x squared. So we think through the functions we know. One function might be x squared, but the derivative of x squared is 2x, so that's no good. But if we think of f of x equals x cubed, then the derivative of x cubed, derivative of f prime of x is the derivative of x cubed, which is 3x squared, which is our original function. That is, we have found a function capital F, so that capital F prime of x is equal to little f of x. That function is x cubed. That's the function that we can use here to evaluate this integral. So the integral from 0 to 1 of 3x squared dx is equal to, what this says it's equal to is capital F of 1, that's the top limit of integration substituted into f, minus capital F of 0, that's the bottom limit of integration substituted into capital F. And so what that's going to be? Well, the function capital F is this x cubed function, so it's going to be 1 cubed minus 0 cubed. F of 1 is 1 cubed, f of 0 is 0 cubed, and that's just a 1. The value of this integral just turns out to be equal to 1. Remember that integral represented area. What we're saying is if this is y equals 3x squared, the integrand, and we integrate from 0 to 1, the Fundamental Theorem of Calculus, Part 2, allowed us to evaluate this area. This area is exactly equal to 1.